That is how much the all-time temperature record in Miles City, Montana was broken on July 12th, 2026. Not tied, not broken by a fraction, not broken by the 1 degree or less that typically separates a record from the previous record in a well-instrumented location with a century of observations, broken by 4 full degrees Fahrenheit, the largest margin by which an all-time record has been shattered in Montana's modern meteorological record. The National Weather Service preliminary analysis from the Billings office was specific. Temperature sensors at airports in Billings and Miles City, Montana, 111 degrees Fahrenheit and 115 degrees Fahrenheit, respectively, and Sheridan, Wyoming, at 109 degrees, all recorded new all-time record highs on July 12th. Each of these stations topped its previous record by at least 2 degrees Fahrenheit. Miles City broke its record by 4. Forecasters did not see that margin coming, and the reason they did not see it coming is the reason this video exists today. The third heat dome of the 2026 North American summer, currently confirmed by forecasters as the most powerful heat dome active anywhere on the planet, did not simply produce more of the same extreme heat that the first 2 domes produced. It produced something qualitatively different. It exceeded the prior records by margins that the models did not project. It is persisting longer than the models suggested it would. It is occurring in the context of drought, wildfire, and compounding soil moisture loss that is amplifying it beyond atmospheric forcing alone. And it has now placed 80 million Americans under heat advisories, with no meaningful overnight relief forecast through early August. This dome just did something that did not fit neatly in the forecast. Let's document exactly what that was. It is Wednesday, August 6th, 2026, day 218 of the year. And today, Planet Brief is doing what the data requires. Not just reporting that it is hot, it is demonstrably hot, that part is covered, but specifically documenting the ways this third dome has behaved differently from what forecasters anticipated, what mechanisms drove those surprises, and what they mean for the remainder of this summer and beyond. Let's get into all of it. Before the unexpected, the expected. Let me establish what the 2026 North American heatwave pattern has looked like across its full arc, because the third dome needs to be understood in context. The first heat dome existed over the eastern United States and eastern Canada from June 28th through July 5th. That event produced the July 4th heat wave that Planet Brief covered extensively. 106 degrees Fahrenheit in Atlantic City, 103 degrees in Washington, D.C., 100 degrees in Central Park for the first time in 14 years, then the hottest day in Albany since 1953, the Salute to Independence Parade in Philadelphia canceled. 44 deaths were attributed to that event. The Wikipedia 2026 North American heat wave documentation confirmed 44 confirmed deaths as of July 8th. The second dome formed over the western half of the continent beginning in early July, targeting the interior west and northern plains. That is the dome that produced what NASA Earth Observatory documented on July 12th. Temperature sensors at airports in Billings and Miles City, Montana, and Sheridan, Wyoming, all recording new all-time record highs with margins of 2 to 4 degrees Fahrenheit. The unexpected performance that opened this video. The third dome, confirmed as the most powerful currently active anywhere on the planet by forecasters writing just over 1 week ago, is the current one. It is targeting the central United States from Dallas to the Dakotas, placing 80 million Americans under heat advisories with no meaningful overnight relief forecast through early August. The No Way Climate Prediction Center is warning of level 3 to 4 extreme heat risk, the 2 highest categories on the heat risk scale. 3 consecutive heat dome events, the first targeting the east, the second breaking all-time records in the west by unprecedented margins. The third, the most powerful, settling over the central U.S. with no overnight relief. Each successive event arriving into a landscape more depleted of soil moisture than the previous one. Each successive event amplified by the accumulated drought deficit that every prior heat dome has subtracted from the continent's buffer capacity. That is the pattern. Now for what forecasters did not fully anticipate. Let me be precise about what specifically surprised forecasters about the behavior of this heat dome sequence, because the word unexpected in the title is a claim that deserves specific substantiation. Surprise number 1, the margin of record breaking in the west. Billings, Montana, broke its all-time temperature record. So did Miles City and Sheridan. That much was in the forecast. High confidence that all-time records would fall was well established before July 12th. What was not anticipated was the margin, 2 to 4 degrees Fahrenheit above the previous all-time records. When a forecast calls for record highs, it typically projects temperatures 1 degree or less above the prior record, because the prior record was itself an extreme event and exceeding. It by a large margin requires conditions significantly more extreme than the previous record conditions. Miles City breaking its all-time record by 4 full degrees means July 12th, 2026, was not just slightly more extreme than the worst day in Miles City's instrumental history. It was dramatically, categorically more extreme, a 4-degree margin that, in statistical terms, represents a movement several standard deviations beyond the previous extreme on a temperature distribution that was already at the extreme end. A NASA Earth Observatory image from July 12th showed the darkest reds, indicating temperatures approaching or exceeding 45 degrees Celsius or 113 degrees Fahrenheit, covering enormous swaths of the western United States. That image was not a projection. It was observational data, satellite and ground station measurements combined through the GEOS atmospheric model, showing what the heat dome was actually doing to the surface air temperature. The darkest reds extended from the Mojave Desert north through the Great Basin, through Montana, and into the Dakotas. The coverage and the intensity both exceeded the pre-event model guidance. Surprise number 2, the persistence. The CNN measure coverage from 5 days ago documented forecasters projecting that, starting August 6th, many regions of the western U.S. can expect new peak temperatures and possible records. The model projections indicate temperatures will soar this weekend with dozens of record-high temperatures in at least 12 western states and about 40 million people remaining under heat warnings. And the continental U.S. could set records with more than 10% of its land area expected to experience its hottest day of 2026 over several days. More than 10% of U.S. land area experiencing its hottest day of the year simultaneously, over several days, not just one. That persistence, the heat dome maintaining its intensity over multiple consecutive days rather than peaking briefly and moving on, was not the central forecast scenario going into the event. The operational models had indicated the dome would begin weakening earlier than it has. Instead, it is maintained and in some forecast products appears to be intensifying before finally relaxing. Surprise number 3, the fire drought heat compounding. The Tech Times analysis published 1 week ago documented this specific mechanism that forecasters acknowledge they underweighted. Fire drought heat events tend to compound and intensify one another rather than occurring independently. The NOAA Climate Prediction Center is now warning of risks persisting into the first week of August for the Southwest, Great Basin, and California, specifically because of the fire drought heat interaction. Here is the compounding mechanism in technical terms. Active wildfires produce smoke plumes that contain aerosols, particulate matter that, when dense, can reduce incoming solar radiation at the surface. This is the negative feedback that fire weather forecasters hoped might temper surface temperatures in the most fire-affected regions. What has actually happened in parts of the Southwest is the opposite. The fires have been producing less dense smoke than forecast. The fire behavior in drought-stressed fuels is producing more intense combustion and less smoldering, which sends more of the aerosols high into the atmosphere, where they trap outgoing long-wave radiation, rather than blocking incoming solar radiation. The result is a net warming contribution from the fires, rather than the cooling contribution that dense smoke plumes can produce. Surprise number 4, the overnight low behavior. The Tech Times report was specific. No meaningful overnight relief in the forecast through at least early August. The specific metric that most concerns heat meteorologists, the overnight low, has been staying dramatically elevated. The NWS heat risk analysis flagged no overnight relief as the specific characteristic that elevates this dome's health impact beyond what the daytime maxima alone would suggest. The mechanism behind elevated overnight lows is documented and has been analyzed in the context of the 2026 dome specifically. Urban heat islands, the concentration of heat-retaining infrastructure in cities, delay the release of daytime heat into the evening hours. When the surrounding landscape is also warm and moisture depleted from drought, the regional pool of air from which overnight cooling normally draws is itself warmer than normal. And when an upper-level ridge maintains strong subsidence, the downward push of air that defines a heat dome, the normal overnight radiative cooling is partially suppressed by the continuous injection of warmer air from above. All 4 of these mechanisms, record margins, persistence, fire drought, heat compounding, and elevated overnight lows, operated simultaneously and in ways that the ensemble model guidance underrepresented in the days before the dome's peak. Here is the specific physical mechanism that best explains why this third dome has exceeded forecast expectations. And it connects directly to what Planet Brief has been documenting across the entire 2026 summer: soil moisture. Or, more precisely, the dramatic depletion of soil moisture across the western and central United States, accumulated through 3 successive heat dome events, a spring and summer of below-average precipitation across the drought-affected regions, and the continuous evapotranspiration demand from 2 months of above-normal temperatures. The NOAA Spring 2026 forecast, published in March, confirmed by the USA Today reporting from that period, explicitly flagged ongoing dryness continuing in the west and drought conditions forecast to worsen or develop for many areas in the west and south central plains. That spring forecast verified with high fidelity. The drought has worsened exactly as projected. Soil moisture across the central and western United States is now in historically low percentiles for early August in most of the affected region. When soil moisture is at historically low levels, when the soil has been stripped of its water content by months of high evapotranspiration demand and below average precipitation, the surface energy balance shifts dramatically. Incoming solar radiation that would normally be partitioned between sensible heat, which warms the air, and latent heat, which drives evapotranspiration, is now almost entirely converted to sensible heat. The latent heat pathway is simply not available because there is no water to evaporate. Every joule of incoming solar energy goes directly into heating the surface and the air above it. The result is that surface temperatures in drought-stressed landscapes exceed what the atmospheric forcing, the heat dome itself, would produce in a well-moistened landscape. By how much? Peer-reviewed research on heat-drought coupling in the western United States suggests a drought amplification factor of 2 to 5 degrees Fahrenheit on top of the heat dome's atmospheric contribution in the most depleted areas. In a worst case, with extreme soil moisture deficit, that amplification can reach 7 to 10 degrees Fahrenheit. Miles City breaking its all-time record by 4 degrees on July 12th, a day when the atmospheric forcing was already forecast to be at or near record level, is consistent with this drought amplification mechanism operating at the higher end of its documented range. The dome provided the atmospheric forcing. The drought provided the amplifier. Together, they produced a surface temperature that exceeded the most extreme prior observation by 4 full degrees. This is the mechanism that forecasters have increasingly recognized is underrepresented in standard operational model guidance. The models represent soil moisture and its influence on surface temperature, but the representation is not yet fully capturing the extremes of the drought-heat coupling that observational data from 2026 is documenting. Here is the specific claim in the current forecasting documentation that I want to parse carefully, because I think it is the most striking data point and the one that requires the most careful interpretation. The CNN-sourced forecast from 5 days ago stated that more than 10% of the continental United States land area is expected to experience its hottest day of 2026 over several days. That is a specific, measurable operational forecast product. The probability that a given grid point will record its highest temperature of the year within a specified forecast window. 10% of the continental U.S. land area is approximately 315,000 square miles. To put that in perspective, it is larger than Texas, a single heat dome event producing the hottest day of the year across more than 315,000 square miles of the country simultaneously, and sustaining that level of intensity for several consecutive days, is not a typical heat wave. It is an event of extraordinary geographic coverage at extreme intensity. And critically, this is the third such event of the summer. The first dome produced record-breaking conditions across the east. The second produced 4-degree margin record-breaking in Montana and Wyoming. The third is projecting the hottest day of the year across more than 10% of the country simultaneously. The cumulative picture? 3 successive heat dome events, each one producing record-level temperatures across major geographic footprints, each one arriving into a landscape more depleted of moisture buffer than the previous, is the signal that the 2026 North American heat wave is not a routine warm summer. It is a summer-long compound event where the successive heat domes are interacting with the drought. They are creating and deepening in ways that amplify each successive event beyond what atmospheric forcing alone would produce. Here is the piece of this heat dome story that deserves specific attention, because it is mentioned in the operational coverage and then left without analysis. The Tech Times analysis from 1 week ago included this specific sentence. The Extreme Heat Emergency Act, introduced by a bipartisan group of senators and representatives, would add extreme heat to the list of federally recognized disasters under the Stafford Act, a designation that would allow FEMA to respond to heat events as it does to hurricanes and floods. As of July 2026, it has not been enacted. Let me be precise about what that means. FEMA can currently deploy resources, personnel, and funding to communities struck by a tornado, a hurricane, a flood, or a wildfire, because all of those hazards are recognized under the Stafford Act as disaster types triggering federal response authority. Heat is not on that list. Extreme heat is the deadliest weather hazard in the United States, killing more Americans annually than tornadoes, hurricanes, floods, and lightning combined. And it cannot trigger a formal federal disaster declaration with the same authority as those hazards. The 44 deaths confirmed from the first dome event alone, with the third dome now producing conditions NOAA classifies as level 3 to 4 extreme heat risk across 80 million Americans, are deaths occurring in the absence of the full federal response infrastructure that a FEMA disaster designation would provide. Cooling centers are opened by local municipalities. Emergency services are mobilized by state and county governments. But the systematic federal resource deployment that follows a hurricane or a major flood The national coordination, the resource prepositioning, the authority to cut through normal procurement timelines is not available for heat. That gap is not a data point in this script's analysis of what forecasters didn't see coming. It is a policy context that exists alongside the meteorological analysis. The heat dome exceeded forecast expectations. The federal policy framework for responding to that exceedance remains incomplete. Here's the operational forecast picture for what follows the current third dome, grounded in what the modeling systems are producing as of this week. The CNN coverage from 5 days ago projected that starting August 6th, today, many regions of the western U.S. can expect new peak temperatures and possible records. Dozens of record high temperatures in at least 12 western states. About 40 million people remaining under heat warnings through the weekend. The heat risk persisting for the Southwest, Great Basin, and California into the first week of August per the NOAA Climate Prediction Center. The specific geographic focus for what forecasters are calling the peak intensity window of the current event, the days around August 6th and 7th, sits over the Southwest, the Great Basin, and coastal California. Death Valley, Phoenix, Las Vegas, and the Southern California interior are in the zone of maximum projected intensity. For the central U.S., the 80 million Americans from Dallas to the Dakotas under the current heat advisories, the forecast is for gradual moderation beginning mid-next week as the blocking ridge begins to show signs of weakening. But gradual moderation from the most powerful heat dome currently active anywhere on the planet is not the same as relief. The heat index reduction from 115 degrees to 108 degrees is a meteorological improvement, but not a public health resolution. The drought that the 3 successive heat domes have been deepening and expanding will not resolve on any human planning timescale from whatever rainfall events eventually accompany the dome's weakening. The soil moisture deficit across the western and central United States represents weeks to months of below-average temperatures and above-average precipitation to reverse. The feedback mechanism, drought amplifying heat, heat deepening drought, does not reverse quickly. The NOAA Climate Prediction Center's probabilistic guidance for August shows above normal temperature probability across essentially all of the western and central United States, extending to the end of the month. The pattern that has produced 3 successive heat domes in 6 weeks is not forecast to break into a climatologically normal summer distribution before August ends. On July 12, 2026, Miles City, Montana broke its all-time temperature record by 4 degrees Fahrenheit. Billings broke its record by at least 2 degrees. Sheridan, Wyoming by at least 2 degrees. The National Weather Service preliminary analysis from the Billings office confirmed all 3 new all-time records in the same region on the same day, each broken by margins that exceeded forecast guidance. That event was the peak of the second heat dome of the 2026 North American summer, an event that NASA Earth Observatory documented with satellite and ground station data showing temperatures approaching 45 degrees Celsius across vast swaths of the western United States. The third dome, confirmed as the most powerful currently active anywhere on the planet, has placed 80 million Americans from Dallas to the Dakotas under heat advisories with no meaningful overnight relief forecast through early August. The NOAA Climate Prediction Center is warning of level 3 to 4 extreme heat risk. Forecasters project more than 10% of the continental U.S. land area experiencing its hottest day of 2026 simultaneously over several days beginning August 6th. The mechanisms behind the unexpected performance of this dome sequence, the 4-degree record margins, the persistence beyond model projected timelines, the fire drought heat compounding, the elevated overnight lows, all traced to the same underlying driver. A drought heat coupling feedback operating in a soil moisture depleted landscape at a scale and intensity that the operational models are underrepresenting. The third dome is still running. The soil moisture buffer that would moderate the fourth dome, if there is one, is more depleted today than it was before any of the first 3. This is what a heat dome looks like when it does something forecasters did not fully see coming. The data documented it in real time. So did the all-time record books in Montana and Wyoming.